Solar eclipses cause the sun, or part of it, to vanish in the middle of the day. While a solar eclipse occurs 2 to 5 times a year, a total solar eclipse happens approximately once every 18 months, but any particular location can go decades to centuries without seeing one. A solar eclipse occurs when the moon passes between us and the sun, casting a shadow on part of Earth. The dark center of the shadow, where the light is completely blocked, is the umbra. The lighter outer part is a partial shadow, called the penumbra. A partial solar eclipse occurs when the sun, moon, and Earth aren't perfectly aligned, causing the moon to only partially block the sun, as would be observed from the penumbra. An annular solar eclipse, or ring of fire eclipse, happens when everything is aligned but the moon is too far away from Earth and therefore too small, leaving a bright ring visible. A total solar eclipse requires both perfect alignment and a closer moon, capable of completely blocking the sun and revealing its outer atmosphere, the corona. The total solar eclipse on April 8, 2024 will sweep across Mexico, the United States, and Canada. Elsewhere in North America can still witness a partial eclipse, but the further you are from the path of totality, the less obscured the sun will be. For those in the path of totality, fleeting points of sunlight shining through lunar valleys will appear, known as Baily's beads. This is followed by a brief flash at the moon's edge called the diamond ring effect, after which marks the start of about 4 minutes of totality. If 4 minutes isn't enough, Delta Airlines, not sponsored, offers not 1 but 2 special 3-hour flights along the path of totality, where diehards can maximize their totality time from 30,000 feet with a view unobstructed by clouds. Between 2024 and the end of 2030, there will be 10 combined annular or total solar eclipses, split 50-50. The next total solar eclipse will be August 12, 2026. Whether during a solar eclipse or in general, please don't stare at the sun with your naked eyes. It's only okay to sneak a peek during the brief totality phase of a total solar eclipse. At any other time, use special purpose solar filters like eclipse glasses to view the sun, noting that sunglasses are not eclipse glasses, and they only block 60% of light rays instead of 99.99%. Failure to use proper eye protection risks burning your retinas, which can lead to permanent vision loss or even blindness. Examples of other light sources that can burn your retinas include welding, laser pointers, and tanning beds. An eclipse is often accompanied by another eclipse, with solar and lunar occurring in pairs, or sometimes even as a trio, spaced about 2 weeks apart. A lunar eclipse occurs when we pass between the sun and moon, casting Earth's shadow across the moon's surface. During a total lunar eclipse, the moon glows red instead of going dark, hence the blood moon nickname. This effect occurs due to sunlight filtering through Earth's atmosphere, as the shorter blue wavelengths scatter while the longer red ones are refracted and reach the surface of the moon. The moon always displays the same hemisphere, called the near side, because it rotates on its axis at the same speed it orbits Earth, a type of tidal locking called synchronous rotation. The hemisphere we can't see is called the far, or sometimes the dark side of the moon, not because it lacks light, but because it's perpetually hidden from our view. The moon is 400 times smaller than the sun, but also 400 times closer to us, making them appear roughly the same size in the sky, a perfect enabler for a total solar eclipse. But the moon is gradually moving away from Earth at a rate of 3.8 centimeters per year. This gradual movement is measurable by bouncing lasers off specialized mirrors called retroreflectors left on the moon's surface by NASA during the Apollo missions. In the distant future, some 650 million to 1.2 billion years from now, total solar eclipses will no longer be possible, as the moon will be too far away, thus making it too small from our vantage point to completely cover the sun. Even with an upcoming total solar eclipse, our sun isn't the sole star in the spotlight. Dracula's Shívido, named for its resemblance to a fanged sandwich, is a newly discovered baby star in the Milky Way. The Shívido is Uruguay's national dish. Dracula's Shívido joins Gomez's hamburger, a similarly shaped star also in the Milky Way, first observed in 1985. Until 2008, astronomers thought Gomez's hamburger was an aging planetary nebula, not a young star. Both stars are located roughly 1,000 light-years away from Earth in relatively empty space, instead of in material-rich stellar nurseries where stars are typically born. These food-shaped young stars are encircled by a planet-forming dense rotating cloud of gas and dust called a protoplanetary disk. When viewed on edge, the cloud obscures the star, forming the fillings, while the bread is produced by light reflecting off the dust. As the protoplanetary disks of these baby stars evolve into planets and moons, there's a chance that some may align just right to also experience a total solar eclipse.